All right, I think we'll go ahead and get started then. So good afternoon, and thank you all for joining us for this session in our Enabling Canadian Innovation virtual conference. All right, without further ado, I'm going to pass things over to one of our presenters, Roman, to get us started today.
So thank you very much again. Welcome to our webinar today regarding Enabling Canadian Innovation virtual launch. And the specific session that we're talking about today is get to the best design faster with simulation. And the question posed there is, why is it important to us? So one of the reasons why it's of importance is to basically reduce the product to market faster. So reduce the lead time, reduce the cost by essentially identifying upfront what your design needs to be so that you reduce the number of prototypes that you build, therefore the less number of tests that you do to build your prototype and identify your problems up front prior to them being built in the first place. So in today's presentation consists of three panelists, three presenters. First will be Jonathan Kalm. He is our solution integration architect. He's going to be talking about SOLIDWORKS and the updates to SOLIDWORKS 2021 and the accompanying simulation tools that comes along with it. Then Mosen Tayefe, our new National Strategic Business Manager, he will be talking as well about some of the technical items related to SoliDWorks, implicit and explicit applications. And then my name is Roman Duplac, and I'm also a new National Strategic Business Manager that has also come along to CAD Micro. And I will be basically talking about some of the SOLIDWORKS premium capabilities, as well as some of the additional plugins that comes along with SOLIDWORKS. So just to summarize again, here's an agenda of our presentation for this webinar. So first of all, we're talking about the newest features and enhancements in SOLIDWORKS 2021 and the accompanied changes that have come along into structural simulation, flow simulation, as well as plastics product line, which is in part also the plastic injection molding simulation tool. Also, we'll be talking about the SOLIDWORKS plugin regarding Simeric CFD, and also the plugin EMWorks, which is an electromagnetic simulation tool for low frequency and high frequency simulation. We'll be diving into the details, which has been a common theme throughout our webinar, the introduction of 3D Experience platform, which is a cloud-based platform that includes, as it mentions the name of itself, 3D Experience, which includes a bunch of tools from CAD design, to simulation, analytical simulation tools, through ERP tools and product data management tools, which also includes SoliDWorks. We'll be diving into the implicit and explicit simulation tools that comes along with SoliDWorks and the valuable design activities that it provides in getting your product to the market faster. We'll then provide some summarizing remarks and then a Q&A period. So our next presenter will be, and I'll be passing on the presentation to Jonathan Kalm. As I mentioned, he's going to be presenting the updates to the SOLIDWORKS 2021 product lines, which includes the structural simulation, which is typically known as just simulation, flow simulation for CFD analysis, and injection mold machine simulation tools for plastics. So Jonathan, feel free to dive in.
Thanks, Roman.
You're welcome.
All right, so we're going to just take a quick look at all the improvements that have been made to SOLIDWORKS simulation in 2021. There's been a couple of really great improvements. So starting with the classic SOLIDWORKS simulation, the structural analysis software that we have a couple of really great improvements here. The first up is they've improved its performance overall with faster contact calculation, faster meshing, and they made it so that the automatic solver selection will actually do a better job of choosing the right solver. It's amazing what they can do with those sorts of things. Up next, there's also some improvements to the contacts and the way they're actually solved, so that there'll be more stability in your models, which is something that can be really helpful. And they've also updated some of the terminology within it. So let's take a look at some of these. I'm obviously not going to show things like the faster meshing, because even though it's faster, not that exciting to watch. But we can take a look at the contact stabilization. So if I take a look into my contacts here, there's an added, oops, did I not click it? Edit definition, there we go. There's an added gap range for bonding in the global bonded, or in the global contacts here. So it used to be that if they weren't touching exactly, the contact wouldn't be evaluated. Now it gives a little range for it to actually generate that contact. So we can see the difference between having that range in place. If I take a look over here, there's actually a little bit of an overlap on these. So they're not exactly touching, and it would fail to create a contact otherwise. So I can see the results with that contact stabilization in there. And then if I set that value to 0, meaning it's requiring them to be in contact, we can see a different result. And so it's very useful to have that contact stabilization. Other things you might have noticed while looking into those component interactions is they've renamed it from contacts. So those would have been component contacts. Now they're component interactions. And they've renamed the no penetration to contact and the allow penetration to free. This just puts SOLIDWORKS more in line with some of the industry standards to make it a little bit easier for people to switch between simulation softwares. They've also improved the mesh quality diagnostics. So I can create mesh quality diagnostics plots now. Well, I always could, but the plots are a little bit improved now, and they will automatically isolate bad elements. So let's just make it so that showing some elements. It will automatically isolate any elements that are not within the range that I've told it is acceptable. Make it very easy for you to see where you need to create your refinement on it. All right, so that's the real exciting stuff for simulation. Up next, we have flow simulation. Flow simulation has some pretty neat ones in there as well. We now have the ability to combine both a free surface analysis with a rotating region. So that's pretty neat. We have improvements to the flux plots. They were added recently, and now they've made them a little bit easier to read. And I'll show those. Goals have been improved to give you some information that you want sort of right up front. We can create plots from a scene to create a template, and that's super helpful to create the same set of plots in multiple different projects. And we can now get the maximum and minimum in a plot, and it will take into account what the cropped region is in that plot. Also, the custom visualization parameters have now been improved to allow you to reference other custom visualization parameters. Let's start off with the rotating region. We can see that in this study, I have a rotating region, and I'm also using a free surface. And so when I get my results, I can see the results from a free surface with a rotating region, helping me solve things that are maybe looking at studies which are mixing or which have a mixer or something in them. It's pretty neat there. The other thing we can do, if I want, I can just show a couple more surface plots or something. Not that one. So I can show a plot like that, and then I can just right click and I can create a scene template. So it'll take these plots, or I can take multiple plots and create the scene template from them. And it just basically takes what you're using and will save it to be reused in another project. So the other thing that we can take a look at is the flux plot. So if I go and look at my flux plots, here I have this flux plot, which has a bit going on in it. There's a lot of different components where heat energy is transferring between them in lots of different directions. And what I can do to be able to very quickly see the energy balance of my system to confirm that it's all working the way I would like it is I now have the ability to group all in here. And so then it will group all components together, all the solids, all the volume sources, and basically show me a very quick view of how the energy is flowing through my system to make sure that it's all set up correctly. We also, as we can see, as I said, we have the custom visualization parameters, which can now reference other custom visualization parameters. So I've got this YTRH, which is referencing a couple of other properties. But then if I go to my dew point, we see that it's referencing the YTRH, which is a custom property which was created. So that's pretty nice to be able to do that as well. If I see that we can take a look at this and see that it is part of a large system here where we're looking at the cooling on the entire system. But if we go and look at the cropped region, we can see that the values would be different for the minimum and maximum. And we can set those values to be, and they will take into account the what the cropped region is only. So if I go to see my minimum and maximum values here, this auto scale to plot maximum and minimum takes into account the cropped region. All right. And finally, we have SOLIDWORKS Plastics improvements. So SOLIDWORKS Plastics has had a couple of improvements too, mostly in just making it a little bit easier to set up your studies with the ability to make now sketch-based baffle and bubblers. There's also the ability to now do multiple material overmolding in the injection process. And they've added a whole bunch, they've added some new materials into the database as well. So let's take a look at this as well. So I go into plastics and create a new study for this. We now have the ability to control the type of injection process here. So we can set it to being a multi-material overmolding process. And I can specify how many different types of injections there are going to be. So I'm going to stick with 2 there. And then I get to specify the type of material for each of those injection units. So I set the material. And you can take my word on it that there's more here. I'm not going to prove that one. So I now have two different materials in this, and then I can specify which unit for each one of these is going to be used. So this is a cavity, I specify which unit it's going to be. So I'll say that one's unit 1 and this one will be unit 2. So it's controlling which injection type is going into each one. And then we can specify our cooling channels here. And these could be sketch based before, but they now added the bafflers and bubblers into it. Let's try selecting multiple at once here. So here's my cooling channels. And then I can add bubblers here, here. And then baffles here, here, something. How they didn't have that before is baffling. All right. So with that, we can pass it along to Mosen, and he can show what's new in SolidWorks, or he's going to talk about what's coming up in Simulia.
So actually it's going to be me first, and then it'll be Mosen. So good afternoon, everyone, again. So we're just going to dive in briefly into the SolidWorks plugins, and then also 3D Experience and how Simulia Works is incorporated in 3D Experience. So welcome, everyone, again. So here for SolidWorks plugin called Simeric CFD. Simeric CFD, it provides quite additional capabilities beyond where SolidWorks flow simulation may have some challenges. So for example, in the lower left corner that you see the animation of the blower pressure animation that's being shown there, it's very similar to a design that I had in my past many years ago, worked in facilitating the design where flow simulation was used, and coming to some challenges in facilitating the design development of a wind turbine, a micro wind turbine that was being used for electric power generation. And so in this situation, Simeric CFD would have been a very applicable tool for some very complex geometries that my ex-engineering colleague and I that were working on together at the time. And some of the other additional animations that you see here is different angles of attack for a vehicle. We want to see what the drag was, the drag coefficients. And here what we see is that the correlation between the animated results coming out of the Simeric CFD simulation are correlated to be very close to what the simulation results were and how they compare to the actual test results. Furthermore, in the diagram up in the upper right-hand corner, you see here a gyromotor pump where you have some variable fluids that are constantly being changed, and also shows very close correlation to the actual test results when we look at the results from Simerics. So that being said, the next slide that we have is another SolidWorks plugin called EM Works. EM standing for electromagnetic works. So in this situation, there are a bunch of tools that allows us to perform electromagnetic simulation of different types of machines, such as power electronics, electric motors, as well as antennas, radio frequency, and microwave components, as well as power and signal integrity on PC boards or any other large electronics that you want to look at. So this gives some additional capabilities beyond what is available currently in SolidWorks simulation. So another wonderful capability that is recently available through SolidWorks is 3D Experience, which is a purely cloud-based type of platform. What's wonderful about this is it provides immediate access. Once you are registered and are part of the subscription, you attain immediate access as long as you have a very good, reliable internet connection, you're able to access all the various different applications and tools that are available on SOLIDWORKS 3D Experience. And the tools that come available on it is your CAD system of SOLIDWORKS, as well as all the accompanying simulation tools that Jonathan was just showing us. In addition to that, it comes with InnoviaWorks, which is an incorporation of the Innovia tool, which is a PLM type of PDM type system as well. So it allows the ease of sharing of data real time when a product is being designed between different locations of engineers geographically throughout the world. You can all be involved as if you're in the same boardroom at the same time. As well as the 3D experience comes with Delmia, in this case called DelmiaWorks, which is a type of ERP system in order to facilitate the incorporation of all the different stakeholders, so suppliers that come into allowing you to manufacture these tools, as well as, well, not tools, but allows you to manufacture the products that you're designing. So it gives you that full comprehensive capability. All these, as I mentioned, these tools through 3D Experience are available, also are automatically upgraded. So any upgrades that come to the software of any of these apps, these upgrades are incorporated. And it's all based on high-speed computing power because the servers are within the cloud system. So very high power computing power software, hardware is incorporated. All of these 3D Experience is also secure, and also it meets all the quality controlled expectations that you would see and like to see. So it involves, from a process perspective, it allows the full, from concept development through design to manufacturing to delivery of your product, is the whole capabilities that 3D Experience provides you. So basically you're able to more expeditiously develop your concept and bring it into the market much faster compared to having these tools on site within your engineering building. And as I mentioned, it's all real-time collaboration. Going on to the next slide. So in 3D Experience, SOLIDWORKS 3D CAD system comes along also with simulation premium capabilities. So again, some of my past life experience that where I have used FEA analyses, and in particular SOLIDWORKS, it has the capability of doing fatigue analysis. So with simulation premium, you have the ability of, in this case, where you see a picture on the left, you're able, where the landing gear is driven by the design of fatigue loading and fatigue cycling, you're able to use SOLIDWORKS simulation to do this type of analysis and do the simulation. Another past work life that I had, where I was a stress analyst for a helicopter company, and I had to do fatigue analysis for the rotor head assembly and the mechanism and individual components as well. SOLIDWORKS simulation can be used for fatigue analysis in this application as well. However, when it comes down to performing impact and crash simulation, especially in another past life experience, I was involved in preparing a manufacturer to design and test for safety certification purposes, in this case for ISO 3471. This was a rollover protective structure, short for ROPS, where the structure was basically connected to a tractor, and all tractors, by the way, have to pass this type of safety certification test. So it's called basically certifying your ROPS structure, so that in the event that the tractor rolls over, that the structure that covers the operator, the structure will not crush, therefore the operator will not be harmed in any way. So in this situation, what needs to be done is when you have a structure that you design and manufactured for taking it to the test facility, the cost of this test, of any specific test, is typically around $40,000 Canadian. So it's quite expensive, meaning that when you come to this test, you want to ensure that your structure will pass the first time, because if it doesn't pass, you have to then go back. It takes a couple weeks or possibly a couple months to redo the design, rebuild the structure, come back and run another test, and which will cost another $40,000. So in this situation, it's best to have a very reliable implicit and explicit simulation tool, in this case, SimuliaWorks, which is in 3D Experience, to help you run your different simulation tests. And in this situation, the test is run from a longitudinal standpoint, as you can see in the middle diagram, and you got to run another test for a lateral standpoint, and then also from a vertical test. And all these tests have to be done not separately, but in series with the damage infused from the previous test. And so in this case, that's where Abacus solving technology, which is part of SimuliaWorks, has the capability to do this nonlinear plastic strain analysis. And it can be done in various, including all the various elements, such as beam elements, shell elements, and hexa elements. And the results of the simulation and the results of the actual physical test, you have to see what you want to obtain the stress and strain plot. So basically a force load with a structural displacement as a function of time. And that's where, in the next slide here, where SimuliaWorks, which includes the Abacus technology, is so helpful in addressing and performing these types of simulations, so that when you do go into your, in this case, crash test of a rock structure, you go with very high confidence of expectation that your test will pass and you'll meet the certification test and only spend $40,000 once instead of multiple $40,000 purchases in your test costs. So SimuliaWorks in the next slide here shows that it comes with various advanced simulation capabilities. It has the basic implicit static analysis capability as SOLIDWORKS Premium, but in the event that you need to run into more nonlinear tests, it has that capability that SimuliaWorks brings. So it can perform nonlinear tests for various nonlinear materials as well, and also you have the capability of calibrating that material. So, for example, we look at the middle column for scenarios. We also see that you can also run not just buckling tests, but also random vibration tests and complex frequency preloading tests. And then in a model perspective, we also are able to perform very intricate, complex, we can mesh very complex structures, which provides challenges in some other tools. So that's one of the great simulation capabilities that SimuliaWorks comes with. And that brings us to the next presenter, Mohsen Tayefe, our National Strategic Business Manager. He has some particular expertise and knowledge in Abacus and SimuliaWorks. And he will go into more detail how explicit simulation tool of SimuliaWorks can be used, and he'll provide the summarizing remarks and bring us into the question and answer period for all of us that we're presenting. So Mohsen, please take it away.
Thank you, Roman.
You're welcome.
So thank you everyone for joining us today. I just want to remind everybody that please use the questions box if you have any questions about the licensing, about capabilities and all of that. We would love to get back to you, and we will answer a few of those questions at the end of this presentation. So Roman talked about a lot of advanced capabilities that SimuliaWorks brings to the table, and extreme deformation, damage, fracture, and failure modeling, general contact, self-contact, and strain rate effects. These are the very advanced parts of simulation that for years Abacus technology was leading, and there are different solutions for this. For example, when we look at this can that is being crushed, so a lot of engineering comes into the picture that is even in the level of science. Like you need to make sure that the plasticities are completely covered. The can impact itself. So that's one of the very tricky contacts, because usually for contact you need two surfaces that contact each other. At the same time, they have to be basically defined as contact and target and all of that, right? So self-contact is very challenging. And then this is happening maybe in a fraction of a second, and material is reacting differently. So strain rate effects are important to be considered. And that's why really to be able to predict what happens it's a little bit difficult to predict that with best practices, even if we have many years of experience. So we need simulation to do that. And now it is available in SimuliaWorks. And because the backbone of this is Abacus technology, you can see test and simulation results, calibration and correlation. These are all aspects that we can really help you guys like to develop those methodologies. But what I want to mention is, yes, we can get some of these from the test, but because this is highly nonlinear, the test management is already very complicated. And also you can see at the bottom, like these images are very valuable because I look at them as MRI for doctors, right? So if I do the test, I don't know what happened. I only have the final shape and I don't know where is the highest stress, where is plasticity and all of that. But simulation can show us kind of like with a wisdom goggle that what is happening inside, where is red, where is blue, and they mean different things, right? That's not all about SimuliaWorks. So from the strengths of solver, that's the leading technology for implicit and explicit solver. So there is no question there. The other part that is also as important is collaboration, because it's not only simulation, is how it is impacting our design process. So in my personal experience in very large organizations, a lot of times analysts and people who are doing simulation come back with some suggestions that industrial designers or other people, they might not like it because it is good for a strength of the part, but it might not be good for the look of the part, right? As simple as that. And you might spend 2 weeks. Simulation Collaborator is something that brings traceable revisions for what if scenarios that creates an efficient engineering workflow. And I want to say, like, Abacus technology is a great thing, but this is as important, like how simulation can be a part of design. And that's when simulation IP can be a corporate asset, because that's included in the design process. This part is very important, and I would like to suggest to all of our customers, look at this part more carefully, bringing simulation into your PDM, into your data management and collaboration. Because you can look at simulation results and just like a test result, but it's just virtual test, right? From your tablet, your phone, and this is web-based. So that's how a team can work together to solve a problem simultaneously, instead of like working 2 weeks and come back and just have some discussions and go back and see those changes were not necessarily what we really wanted. One of the applications that we see here, SGA is one of the very important companies in safety for rail industry. You can see in this specific case, we have bumpers that, because this company makes a lot of vibration components and flexible joints, bumpers, bushings. This bumper after impact goes through huge deformation, so nonlinear large displacement. Thermal induced stresses, because there is rubber and then there is a metal outside, they don't expand similarly under temperature loads, right? So these are very different, and they have to operate on in minus 30 degrees C and plus 50, whatever, right? So to be able to design something that works in all those scenarios, and for a company that safety is priority, so there is no room for estimations or wrong estimations. That's why they use SimuliaWorks, because it gives the high tech and basically accurate results within the design environment. That part is very important. Like, I have been in simulation industry for 20 years, and really, like, honestly, having simulation as a part of your design process is very important. Like, having that because the final goal is not a scientific paper, for example, right? So it's really the product to be developed in a proper way, faster, and for the company to have more profit. One of the items that actually helped on that specific example is accuracy of material modeling. Abacus technology always was famous one for having complete material platform, hyperelasticity, hyperfoam, viscoelasticity, and elastic plastic methods, kinematic hardening, isotropic hardening. All of these, if you know them, great. If not, we will be able to have some trainings for you, because you need to know these basically theories to be able to use them. So we are planning on trainings before the end of this year, so to be able to help our customers to use the technology faster. But let's go back to material calibration. Actually, within SimuliaWorks, there is an app that everybody can use it, like the users of SimuliaWorks, that you can bring your test data from a text file, and then this app will smartly select what material model is better for that test data. For example, in this image that you see on top left, because I have just a stress strain curve in a static way, actually SimuliaWorks is proposing plasticity, Johnson-Cook plasticity model, and that's it. Like on the right side, you see the top right red line. On the bottom side, you can see, because I have more information, and SimuliaWorks is that, okay, I have volumetric strain, I have one-dimensional strain, bi-dimensional, and all of that. That's why it recognizes that this is rubber, and it is proposing Muni-Rivlin material model. And I don't need to actually calculate those parameters. I need 3 parameters, but how I can calculate those parameters from 3 pages of Excel file that is coming from test, that's done in the background. So this is very important, and I want to encourage everybody to pay more attention to this capability of SimuliaWorks. With this type of accuracy and taking everything serious in the because I always mention that we are virtual creators, because in the computer, whatever we define, basically SimuliaWorks will work on it, right? So if I don't put gravity, things are not dropping. So that's why we have to be careful about physics, and that's why like material model is there. In this specific example, I'm talking about sealing systems on the left. Sealing systems are very important, because if you have underwater robot that goes to maintain or inspect something, you need to make sure that the sealing system works, because electronic and all of that, and in many different applications, biomedical and all of that. So in this example, like you can see when the parts are engaged, very accurately we can find what is pressure between different surfaces, and are they enough for keeping the system cool and dry or not. So and we can design these like the components differently. More importantly, now with our 3D printing capabilities and additive manufacturing, these components, they don't have to be the same material. For example, the areas that are in contact in a flat area, they can be more rigid, and then we can have more flexibility on the other side. Even there are technologies that we have, and I'm excited about it, that there will be carbon fibers during 3D printing that they can be injected, so we can have a functionally graded material, right? So those are the areas that we would like to talk with you guys. And on the simulation side, we have expertise in it, how to model it, methodologies, and all of that. On the right side, you will see a little bit extreme deformation that is pretty hard for a lot of solutions that are in the market to be able to converge in such a self-contact, nonlinear deformation and hyperelastic model. One of the areas that actually SimuliaWorks is going to be very helpful is when we are dealing with severe, highly nonlinear applications. Just as an example here, sometimes human body, right? As you can see on top, like I have bones and muscle and everything modeled, and now I want to see how an impact can be painful or not, right? So that's pretty challenging analysis, and we can do that. Aside from traditional simulations like a static and modal and all of that, one of the very important aspects of simulations for products is drop test impact, because we want to make sure that if we are designing, let's say, prosthetic foot, then it is working during impact. But let's say if I ignore impact analysis and impact calculations, and I just do the design, sometimes electronics are involved, sometimes like look of the product is involved. I do all of those aspects, and then at the end I go for an impact test and it fails. I think it can be very painful, and the level of pain can be really high, because after 3 or 6 months of product development, you might need to go back to basically your initial design changes. Okay. So now I want to come out of those examples and kind of look at the simulation on a higher level. As always, that we see simulation as something for companies to save time, cost, and reduce the pain of product development. Really, the final goal that I see here is that at the beginning of design process, we should be able to end validations. How it works in a regular method of product development, we have concepts and R&D working, and they design a concept and prototype, and then we do prototyping, we do test. For example, in this specific case is a robotic arm that actually has to go on a lot of market requirements and regulatory tests. After that, when those tests are passing or not passing based on the results of those tests, specialists, we review that, they go back and change the design. Look at this a little bit more carefully, like basically, let me see. Okay, so on the left, you will see like there is a PCB that yesterday we had PCB webinar, right? So about which is based on Altium, and these days PCBs are not just rectangles anymore, right? They are sometimes flexible and sometimes different pieces, different shapes. But my point is here a little bit more holistic. I have a PCB here that is almost touching the cover, and there are a lot of different pieces there, like battery, CPU, and some optical devices and all of that. And there is a cover that is, because we want to make everything smaller. Now there is no room for thermal cooling, and there is no room for EMI, EMC interferences. And so everything is just more challenging. So passing all those requirements and regulatory things in the actual test is going to be very painful, because actually we have to wait for the product to be available. But with simulation, we can validate those actually in a simulation environment without having the products in hand. And I know this is what most of us know it already, but the point is, because now we have all these advanced technologies for FEA, for CFD, for electromagnetic, for PCB design, all within SolidWorks, that's really the thing that I see like the industry needs. And that's the real simulation-driven product development. Because it's not only simulation that is important, how it is integrated with your design process, with your PDM, and how to be able to go from design and do simulation, do like, let's say, parametric study, optimization, and all of that, and be confident about it. Okay, now I'm confident because I did the right simulation, and I can just go to do a physical prototype. Maybe there are small tweaks, and instead of 10 different iterations, maybe with 1 iteration, 2 iteration, we can reach to the production level. This example is a very important example, and I like it. I have worked on drop tests of cell phones and electronic devices and all of that, or for example, for waste management, like like containers that they have to be safe during transportation and all of that. So we will be able to help you if you are dealing with impact and drop test methods. So far, like I want to talk about what is changed in 2021. Shock, vibration, thermal cooling, all of that was already available in SolidWorks simulation. But now with this explicit dynamic availability in SimuliaWorks for this cell phone, even though we were able to do a lot of analysis, now we can do more. For example, you can see during this drop, I can see the performance of the rubber that is actually the cover for the cell phone, and how during that drop, it is distributing the energy throughout the time. That way, as you can see here on the right side, the glass is broken because there is no rubber, and the impact is sharper and energy goes to the glass, right? So these are the level of capabilities that we can do now right inside SolidWorks. This is a very nice example, and I like it. At the end of the day, let's say I have a handheld device, and it is designed by SolidWorks and all of that. But when we are manufacturing this device, let's say any of these components, probably even injection molding, 3D printing, or any other method that we use, probably geometry is not exactly as it was designed, because thickness can have a little bit variation. There might be air traps, there might be sink marks, and there might be warpages because of thermal stress. All of us are aware of that. During all of these analysis that we are doing in real life, let's say drop test or thermal or vibration, really the product doesn't care what was in the CAD. It cares what comes out of manufacturing. So that's why our 3D scanning and metrology platform that we have, actually GOM, like the best one, like within our company and our team, we can actually 3D scan the parts that are critical, and then use the geometry of as manufactured, not as designed, as manufactured, and bring it into our drop test analysis, vibration analysis, and all of that. For example, if this part is injected molded, basically with the injection molding process, we can build different parts. But definitely the thickness, if the thickness is 2 millimeter, maybe it's 1.9, 2.1 at some specific corners, and those corners are important because there is a stress concentration there, right? So I want real thickness, not the design thickness. That's why I really encourage you guys, if you are dealing with this type of applications, let's talk and see how we can use more modern technologies for your basically you can have a better product at the end of the day. You can predict better. And also, like through SolidWorks Classic that Jonathan talked, we can simulate the process of injection molding. And again, as an output of that, we can export thicknesses that are output of that into our simulation. These are the areas that we are very excited. We have done it in the past, and we will do it again. The last application that I would like to talk is metal forming. Metal forming in many cases is high-speed dynamic, but still very accurate because we need the final product to be accurate. So that's where our SimuliaWorks can do it, and it requires both implicit and explicit together. In a deep drawing that you see on the right side of this slide, at the beginning, very high-speed deep drawing will happen, so that's explicit dynamic. After the drawing is done, we release the part, and now the part needs to have a spring back. That spring back is completely implicit. This is very challenging for any other solution rather than Abacus technology that has both implicit, explicit within the same solver. On the right is a thermal forming, and basically we can do the same sort of like forming. It can be for plastics, it can be for other material in different temperatures. So thermal stress and having thermal calculations within our implicit and explicit solver capabilities are available. just to summarize all of our technologies, today we talked, like Jonathan, Roman, and myself, we talked actually about all these products that you see here. So some of the standard simulations, Jonathan talked about it, and then Roman and I talked about our SimuliaWorks, SolidWorks Flow, and Simerix. We talked about CFD, just to have it kind of like a slide for you guys to organize what we talked about it. And then plastics is the one that I talked about, and Jonathan talked in more details about injection molding and electromagnetic calculations. Thank you very much, everybody, for joining us. We are very happy about the attraction that this session had, and many people joined. I transfer the floor to Jessica for questions.
Excellent. Thank you so much to all three of our presenters, Jonathan, Mosen, and Roman. As promised, we do have some time left for some questions, and we do have a couple in the queue already. So I think we'll go ahead and get started. So the first question I have here, I'm going to throw it your way, Mosen. The question is, sure. How do you compare SimuliaWorks, Abacus, ANSYS, and LS Dyna?
Okay, that's a tricky question. First, I think on top of anything that I want to say, all of these products that you mentioned, they are great products, and they do simulation. A lot of products in the market are designed and analyzed with these products. But I understand the question, like how we can compare them. Let me go to one of the examples. Actually, Roman was talking about it, so I have it here. This example that is actually a very important example for certification, and it applies to many industries. Like, for example, I have done this project for mining industry because you have like protective structure, and Roman also had experience with this with other industries. For example, let's go into more details. During this example, there are areas that we need to do implicit analysis. For example, extreme load, but in a quasi-static way, to see how the roof is deformed. And that deformed shape has to be initial geometry and initial model for a drop test or impact analysis. So consider this example, and I go back to the question. So in these examples, we need to do implicit and explicit analysis in sequence. Sometimes in deep drawing example that I mentioned, at the beginning, deep drawing happens, it has to be explicit. Then the spring back has to be basically implicit. Sorry, the deep drawing is explicit, and then the spring back is implicit. So the nice thing about SimuliaWorks, which is based on Abacus technology, is that Abacus has both of these solvers basically within one solver platform, right? So the code, everything is the same. ANSYS can do implicit analysis. So on the implicit side, it is close to Abacus, and some areas like they are shoulder to shoulder, really. Like some capabilities on the material and nonlinearity, maybe convergence Abacus is better, and there are some other areas for ANSYS. And then, but when it goes to explicit, ANSYS doesn't have anything. It has to be transferred to LS Dyna. And ANSYS purchased LS Dyna 6 months ago or something around that. But that doesn't mean that LS Dyna is integrated to the solver of ANSYS, because ANSYS is kind of like Fortran, and then LS Dyna is keyword manual, and guys that they used it, they know what I'm talking about. So really the integration of these implicit, explicit solvers is going to be very difficult for actual applications. And more importantly, to me, because I also mentioned that simulation is really important and good, but having that for designers is also very important. So SimuliaWorks is available inside SolidWorks. So that's another aspect. Let me check the time. And I think I want to also talk about the licensing of these products that you mentioned. SimuliaWorks, which is based on Abacus technology, with one license, you will have access to implicit, explicit, HPC, cloud, and local computing. So it's one license that can change its own like behavior, right? So you pay for one license. But if you want to do the same thing with ANSYS and LS-DYNA together, so you need to buy ANSYS Mechanical, which is the top like enterprise level of ANSYS, plus HPC for that license. Then you need to have LS-DYNA and HPC for LS-DYNA, and then you need to have a CAD connection. So really to do the same thing, you need 5 licenses, and you have to park them and use one at a time, while you always use only one of them, right? But you need to keep 5 of them, and they don't talk with each other. Like they have to, from licensing point of view, they are different businesses. So really from licensing and management of IT is very, like a little bit more challenging. Like I think managing 5 licenses is instead of 1, but more challenging is when you want to pay for 5 licenses. And then basically, really, I think from cost point of view, technology very similar, but cost is probably fraction with SimuliaWorks. So I hope I answered that. It was a very good question. So if there is any more question in that regard, please contact us. We will have separate discussions, and we are open to any sort of questions you have.
Perfect. Thank you, Mohsen. We are almost out of time, but we do have several more questions. So if you guys are happy to stay on with us, we will get through the rest of the questions we have in the queue here. So Jonathan, the next one I have, I'm going to throw your way. The question is, how seamlessly transferable are any CAD-based models to SolidWorks Simulation or SimuliaWorks?
Well, that's an easy one. They're really seamlessly transferable. There's you got a nice connector that gets installed with your to your SolidWorks, and you can just access it from the task pane and transfer the models there. You'll even bring through the contacts and material definitions that you've already placed on it. So it's super, super seamless.
Awesome. Thank you, Jonathan. Roman, I think this one might be best for you. So the question here is, what is the selection criteria on when to use SolidWorks Structural Simulation or SimuliaWorks?
Yeah, so the real key difference is 2 things, actually. If you just required to do simply a linear analysis, then you pretty much can stay with SolidWorks Simulation. Once you need to get it to explicit simulation analysis, especially using other terms to express that nonlinear analysis or plastic deformation or any crash or simulation type of work, that's when you need to take on and work with SimuliaWorks, which is supported by Abacus. And just to add more credibility to that, 2 very key customers that have actually accepted the whole platform of 3D experience is Tesla and Pratt & Whitney Canada. Both of these companies use 3D experience SolidWorks, which includes Simulia. So I think that answers the question.
Perfect. Thank you, Roman.
You're welcome.
Mohsen, another question for you here. The question is it possible to explain where and how the validation of the models takes place in a design cycle of highly nonlinear products?
Yeah, so that's a very good question. So it's always a little bit difficult to make sure that when we are doing simulation, especially when we are working on highly nonlinear examples without having the actual test, basically how we can calibrate these models. That's where we have our experts like to work with our clients. We have different methods. One of the methods is that we try to analyze the methodology. Let's say if during my analysis I need to have a like highly nonlinear material model, is that nonlinearity coming from contacts? Is that nonlinearity coming from geometric nonlinearities, or combination of all of those? So we divide them. So we make sure that our material is calibrated, and then we look at all these elements that are building up the full nonlinearity system. And I want to I'm very glad that to highlight the fact that there are a lot of literature available for Abacus technology that is now in SimuliaWorks. So what we do, and I have done for years, is that we make sure that we find similar examples that are done and compared with tests. Let's say on the example we talked about the crash of the roof and rollover, there are many examples that basically that highly nonlinear situation is simulated. So we try to actually validate our methods and our approach, and then we apply that to this new product. And also our engineering judgment is always behind that. So SimuliaWorks is not going to replace engineering judgment for sure. So that's why that's why when I talked about training, like for example, when we talked about that material and material calibration, it's not only to import the text file and just take that to Abacus solver. It's actually in our trainings, probably 60–70% of our training is theories of plasticity material. Like we need to know what are these numbers that we are using. And we are very excited to be able to deliver that to our Canadian customers.
Great, thank you, Mosen. Another question that's just come in here is, how about the coupled interaction of solid and flow, like moving solid boundaries with flow motion? To what extent can SolidWorks be relied?
Yeah. So basically, one of the area that this is a question that depends on what type of fluid structure interaction we are dealing with. For example, it can be a bird structure. Like I have a bird that is represented by fluid, and it's impacting a composite wing of an airplane. So this is doable here, right? So depending on what kind of interaction we are looking at, or the other part can be fluid structure interaction in dam and spillways, right? Or during earthquake, when behind the dam you have water and the earthquake is happening and that water is deforming the gates and all of that. All of these applications that I mentioned to you guys are doable with our technology. So really, like I would encourage the person who had that question to contact us. We have a specific discussion with them, but just one of the items that is my favorite item in explicit dynamic is SPH, which is a meshless method. And that's how we use fluid inside the structures. And actually we have one example, if you guys are interested, we can share with you. And it's like a bottle that you have water inside, and now you are crushing it. After crush, like the bottle would be kind of exploded and the water comes out. So this is what one of our examples in SimuliaWorks. Again, like I definitely would like to get back to the person who asked that question to make sure that what type of fluid structure interaction we are talking about.
Actually, I'll just comment to that briefly as well. If the person is asking about specifically moving boundary layers in the CFD analysis, Simeric's CFD does that quite readily. So, however, it'd be better, as Mosen was saying, to have a more in-depth conversation outside of this webinar to understand the context what the question is coming from. So we encourage that person to come forward and have a more detailed discussion outside of this webinar.
Perfect. Thank you very much, guys. There are a couple of comments or questions that have come through about whether we're going to be making the recording of this session available, and we certainly will. We'll be sending that out a little bit later this week after the wrap up of our session, our whole launch series here this week. So we'll be sure to get the recording to all of you guys. And if you have any further questions for our presenters, you can always respond to the GoToWebinar email that you'll receive from us, and we can follow up with you that way. So I think that's about it for time for us today. Once again, thank you very much to all of our presenters, Jonathan, Roman, and Mosen, for a great presentation. And thank you all for joining us today for this session. So thanks a lot, everybody. Take care, and we hope to see you soon.
Thank you very much. Bye-bye.
Thank you very much. Take care.